Okay, hey folks, getting into these next modules. So the remaining three are going to be on photochemistry. And I first want to set the stage by just briefly describing the difference between base E and base 10 spectroscopy, which we've talked about briefly, but I wanted to make sure we had that discussion formally here in the lecture notes. So we start with some absorbing sample in some cell with path length L, typically given in units of centimeters, but not always necessarily. And in that sample, we are irradiating it with some incident beam of light. Some of that light gets absorbed. Of course, some of it also gets backscattered. All of the same, only a fraction of that will make it all the way through and become the transmitted beam I. If we could look at how much light is attenuated through the sample as a function of distance, we would see that it has some exponential decay, and that decay is given by e to the negative tau, which is the optical depth. Okay, so as you can see right here right away, that e to the negative tau is the transmittance, or as you know more recognize it, I over I naught. So in the case when the transmittance is 1 or 100%, that means I naught equals I, and nothing in this sample or sample container has scattered or absorbed the light. Similarly, in the optical depth, when I naught equals I, and notice it's the opposite ratio of the transmittance, right? So in that case, that for 100% transmittance, that would be an optical depth of 0. So for opaque medium, or media that will scatter or absorb light, the optical depth will increase from there. So a large optical depth means we have an opaque sample. So in other words, it's absorbing some light. So now if we think about how that compares to the absorbance, you can see the absorbance A and the optical depth tau are almost identical with the exception of a difference in the natural log, right, versus the base 10 log. So the natural log is what actually happens naturally, but historically we've used the base 10 log because that's an easier calculation to perform, particularly if we didn't have a computer or a calculator, right? So we can also see that absorbance is related to transmittance in a similar way as transmittance and optical depth. However, with absorbance, it's the negative log base 10 of the transmittance. And then now if we wanted to interconvert absorbance and optical depth, we have to remember to use that switching of the base, the natural log of 10, 2.303. Okay? So, but hopefully what you've gathered now, the absorbance and the optical depth will scale in a similar way. So as the optical depth is larger, or a thicker optically depth material, that owes to a larger absorbance. So now looking at the Beer-Lambert law, base 10 or base E, so what you're used to seeing is this base 10 law, where epsilon is our molar absorptivity. Okay, and that's in units of inverse concentration, inverse centimeters, liter over mole centimeters. Of course, concentration, we recognize, is in mole per liter, and thus, as we said, the path length is given in units of centimeters. So now in the base E version, notably here, we still have the same path length given in centimeters. Now N stands for our molecular density given in molecules per cubic centimeter, which means sigma here is our molar absorptivity coefficient equivalent, but that is what we call the absorption cross section. I spelled that wrong. It's a B, not a P. Absorbance cross section. Okay, and so if we go through and do the units, you'll notice then that that has to be square centimeter per molecule. So we really can think of it as this cross section, right? So imagine if we've got a whole bunch of beams of light coming in, right? And we put a molecule in its way, so we could approximate that molecule as some cross-sectional area, sigma. And so some of the light will transmit right through, and some of it will get blocked by that cross-section. So it's not the same as like a physical cross-section, where the size of the molecule gives the size of the absorbance. But this is a nice equivalent way of thinking about it in terms of the units. Okay, so we'll pick up more on this in the coming videos with photochemistry. I'll see you then.